Today we're going to talk about solving angles using transversals. And we're going to start off by defining a transversal. So given a pair of lines, AB and CD, in a plane, which is our diagram down here, a third line, EF. And EF should have the little symbols, if it's going to be a line, should have the symbols on top here. And there we go. Third line EF is called a transversal if it intersects AB at a single point and intersects CD at a single but different point. The two lines AB and CD are parallel. I gotta fix those, sorry. Are parallel if and only if the following types of angle pairs are congruent or supplementary. We have corresponding angles are equal in measure. Well, corresponding angles, if you cut this diagram in half, corresponding angles would be the angles in the same relative location. So a few pairs of the corresponding angles would be angle A and angle E. Angle A and angle E. Because if you look, A and E are in the same relative location. Another example would be D and H, and we could keep going from there. Angle D and angle H. That's another pair. There are four pairs of corresponding angles. The second type of angles, when lines are cut by transversal, are alternate interior angles. So alternate interior angles, if the lines are parallel, if AB is parallel to CD, alternate interior angles are equal in measure. So alternate interior would be on opposite sides of the transversal, but inside the parallel line. So C and F, or D and E. So angle C and angle F, that is a pair of alternate interior, and angle D and angle E. So those measurements are equal. The measure of angle C is equal to the measure of angle F, and the measure of angle D is equal to the measure of angle E. And you can look at it. In most cases, even though drawings are not to scale, you can tell that E and D, they look like they're the same measure, and C and F look like they're the same measure. And then the other fact, if those two lines are parallel and cut by a transversal, is that the same side interior angles are supplementary. So if you look at C and E, they're going to add to 180. So C and E, C and E, that's same side interior, and D and F. Those are also same side interior, and those are supplementary. And again, in most cases, if you look at them, you can tell they're not congruent, but they do add up to 180 degrees. So we're going to work through some basic problems and then kick it up in the complexity a little bit. And for all of these problems, I don't tell you anything, but if you look at the symbols right here, these symbols mean that the lines or the line segments are parallel to each other. So if you see in all cases, we're going to start with the fact that they are parallel. So all four of these cases are parallel lines cut by a transversal, and this is the transversal right here. So if I want to find angle A and angle 48, I'm going to, the 48 degrees, those are corresponding angles. I'm going to label what they are. Corresponding angles. So corresponding angles, if parallel lines are cut by a transversal, corresponding angles are equal to each other. So the measure of angle A is 48 degrees. The second one, these are same side interior. So I'm going to label it, they're same side interior. I'm not going to write the full statement yet, but we will get to that in a few units. So if parallel lines are cut by a transversal, then the same side interior angles are supplementary, meaning they add to 180. So B plus 48 is equal to 180. Solving for B, subtracting 48 from 180, you get 132. So the measure of angle B is 132 degrees. Angle C, when you look at part C, these are alternate interior angles. Alternate interior, So we know that alternate interior angles, they are going to be equal to each other. So angle C is going to be 48 degrees. And then the last one is angle D. Now angle D we didn't specifically label, but it's similar to alternate interior. These are alternate exterior angles. Now even though that doesn't look like it's 48 degrees, we have to go by what we're given and not necessarily what the scale should be. So these are alternate exterior angles, and they have the same, I've got to fix that E over there, the same properties as alternate interior. And they are going to be congruent. So the measure of angle D is also 48 degrees. Now when we start to do more complex problems, an auxiliary line is useful. So let's see if I can spell this. Auxiliary. An auxiliary line is sometimes useful when you're solving for unknown angles, especially when you have the parallel lines, because we can create a third parallel line helping us to split up our problem. So we have a figure here. In this figure we've used an auxiliary line, which is the dashed line, to split up angle W. By doing that and saying that this auxiliary line is going to be parallel with the other two, I have now a set of alternate interior angles that I can use. So we split it up into an angle E and an angle F. So let's talk about this. Angle 41 and angle E. Now that I have this third parallel line, angle 41 and angle E are alternate interior angles. So the measure of angle E is 41. The same thing happens with angle F. Now that I've split up W, F is going to be 35 because they are alternate interior angles. So the measure of angle F is 35 degrees. The measure of angle W is just the sum of those two. So that's going to be 41 plus 35. And it looks like the measure of angle W is 76 degrees. We could not have solved that very easily without using that auxiliary line to break up angle W into two alternate interior angles. So I'm going to work through a couple problems here, and then during class we'll be working through a few more. Okay, so the first problem actually has several parts to it, and we're going to break it down into pieces. I have, the only two parallel lines I have right now are this one and this one. So I can't really get to A. I could extend this line, but I still don't have a lot of information to go by. I have the fact that this is 310, so that tells me I'm probably going to use angles around a point. And then I have these two lines over there that aren't very helpful right now. So here's what I'm going to have to do. I'm going to have to put in, when I see angles right here in the middle, it kind of tells me to put in an auxiliary line there. So if I did that, if I put in an auxiliary line here, what that tells me is that A is here and also up there, because these are interior, alternate interior angles, because this is going to be parallel. So I have three parallel lines. So I'm going to put a little A right there. Well, if I can find the other part of that, then I know I can subtract all that from 360 and get the answer for A. So I need to find this guy. Well, if this is a parallel line and this is a transversal, if you follow it up, I'm going to need another parallel line there, so I can draw that in. Okay. So I have this guy and this guy. Well, I got nothing in there. However, on the other side, I've got 110 and 80. So here's where it gets goofy. 80 is this full thing. I can find this piece of it because this piece plus the 110 are supplementary, same side transversal. Okay, so we'll start there. That little piece is going to be 180 minus 110. So this piece up here is 70. If I blow this up, I'm going to blow this up over here. Let me blow it up better, because that doesn't look good. Okay, if I blow this up, and this is 70, and the entire thing is 80, that means this little guy down here is 10 degrees. So if he's 10, then this is 10. Now I can solve for A. Alright, he's got to go away, because he's in my way. Okay, so to solve for A, I know the angles around a point add to 180. So A plus 310 plus 10 is equal to 360. A plus 320 is equal to 360, and A ends up being 40 degrees. So if I were to list the reasons for my solutions, angles around a point add to 360. That was our final thing. If parallel lines are cut by a transversal, then alternate interior angles are equal. Same thing up here. And if parallel lines are cut by a transversal, then same side interior angles are supplementary. So that took 3 different reasons to figure out that problem. Okay, the last problem for your notes, we don't have to draw any auxiliary lines here if we look at it, because here's what I have. I want to find the measure of angle B and the measure of angle C. Well, right off the bat, I have a parallel line and a parallel line cut by a transversal. So C and 46 are alternate interior angles. So right away, I know that C is 46 degrees. Oh, I gotta write that better. The reason being is if parallel lines are cut by a transversal, then alternate interior angles are equal. The second part, for part B, now that I have C is 46 degrees, well, I have a triangle, so if I can find this piece, I can find B. Just using an old theorem, the sum of the angles in a triangle add to 180. So right here I have 94, and it's a linear pair to the other side. So if I subtract 94 from 180, because linear pairs add to 180, I get 86. So this is 86. And I know the sum of the angles in a triangle just from previous classes, that adds to 180. So B plus 86 plus 46 is equal to 180. And when you solve, you end up with B being 48. So in class, we're going to do quite a bit of practice of using auxiliary lines and solving for angles when a transversal cuts parallel lines. Here's just some basic definitions. Again, we're going to define alternate interior angles. When 2 lines are crossed by another line, which is called the transversal, the pairs of angles on opposite sides of the transversal, but inside the 2 lines, are called alternate interior angles. Notice, I don't say anything about lines being parallel, so the lines don't have to be parallel. Okay? I can draw them like that, and those 2 are not parallel. But alternate interior angles are still like this guy and this guy. Okay? X and Y. Those are alternate interior, so they don't have to be congruent. If the lines are not parallel, they won't be congruent. Corresponding angles uses that definition. So let line T be a transversal to lines L and M. So I'm going to draw L, and I'm going to draw M. They aren't necessarily parallel, and there's line T. If angle X and angle Y are alternate interior, there's X, there's Y, and Y and Z are vertical angles, then X and Z are corresponding angles. So that's how you can describe what corresponding angles are, right here and right here. You get there from alternate interior and vertical. And in class we'll be practicing a lot more of these problems, especially using auxiliary lines.